Okay, so we've got the price of eggs, kind of sampled stores in this particular region, however big a region it is, but this is the price of eggs for these 10 stores in Region 8. That would probably be for half a dozen eggs now. All right, but this is what we're going to go with. All right, so if I want to get, so we're talking about standard deviation here. If I want to get the standard deviation for this, what first do I have to calculate? Because the standard deviation is based on deviations, and deviations are based on the mean, right? So if we don't have the mean, we've got to first of all calculate the mean. And so the mean is just the average of all those values. 70 plus 68 plus 72, 60, 63, 75, 66, 65, 72, and 65. Okay. I get that to be 676. Did I check me on that? 676 divided by the total number of values there are in 10, so that's 67.6 is the average. Okay. Now here's what we're going to do to help us. I mean, you know, use a calculator. It can, or computer or something that could calculate this more accurately. But for our purposes, let's round that to 68 to make it a little easier on ourselves. Because when I do all these, I mean I could do them and then square them, but it just leads to a lot of decimals, and so I'm okay with this. Let's just round that to 68 to make it a fairly nice computation here. All right, so to do the standard deviation now, first of all, I need these deviations, which is just value minus mean. Is all I'm doing here. So that's what I was saying. If we use the 0.6, it'll lead to decimals and then more decimals, which is fine, but let's do it with the whole numbers here. So what have I got? Deviation here, 2, 0, 4, -8. So I'm just subtracting 68 from each of these. -5, 7, -2, -3, and 4, and -3. Sound all right? Everybody believe that? Now I'm going to square those. So we've got 4, 0, 16, 64, 25, 49, 4, 9, 16, and 9. Gets rid of all the negatives. So far so good? So our standard deviation then is I take all of these added together. I'm not going to write them out. 4 plus 16 plus 64 plus 25 plus 49 plus 4 plus 9 plus 16 plus 9. I get that to be 196. Check me on that. 196. Sound about right? Believe that? Sounds about right. Okay. All right, now I'm going to, then I need to divide by n minus 1 here. So I take 1 less than the number of values there are, so I divide here by 9, because there's 10 total values, so standard deviation you divide by 1 less. That's the way it works. So divide 196 by 9, so that's the square root of 21.7 repeating, looks like. And that is 4.67 is our standard deviation. For this particular grouping here. All right, good with that? All right. Now, here is the second part to this problem. Okay? Let's say I wanted, or I had, so in region B, here's the calculations. The mean price of eggs is 70 cents. And the standard deviation is 2.01 cents. All right, so you compare those two. But here's a couple of questions about that. So comparing region A and B, number one, which region's prices are higher on average? Which region's prices are higher on average? So this is kind of asking about, do you know what these quantities represent here? Which quantity represents the average out of our statistics we've talked about so far? Which one's talking about average? Well, we've got the mean and the standard deviation here. Which one talks about the average? That's mean, isn't it? The mean is the average, so which region's prices are higher on average? I'm going to go with the higher mean. All right, so the mean here of region A, we said 68. Region B has 70, so which region's prices are higher on average? Region B. It's got a mean of 70. With me there? Okay. All right. Number two. Which region's prices are more dispersed? Which region's prices would be more dispersed based on our calculations and given data here? Which region's prices are more dispersed? Well, what tells us about dispersion in our statistics? Well, based on the ones we have here, it's the standard deviation, right? The standard deviation tells us about dispersion. And so the more dispersed, we want the higher standard deviation. So which one has the higher standard deviation? We got 2.01 for B. We got 4.67. So it looks like A's, right? Region A. All right. Okay? Everybody okay with that? Got a third one though. So we know which ones are higher on average, which ones are more dispersed. Here's the next one. Which regions' prices are more consistent? Which region's prices are more consistent? All right, let's think through that. So if they're more consistent, what does that mean? Well, if they're more consistent, they're closer together, which means less dispersion. Right? So what am I looking for as far as statistics go? The smaller standard deviation, right? Yeah. If I want more consistency, I want a smaller standard deviation. So the smaller standard deviation was B. Region B would be the more consistent ones. Okay? So it works a little opposite there. More dispersion is a higher standard deviation, more consistency is a lower standard deviation. Okay? Is that all right? Question or concern?